Hey everybody, I want to talk to you about exponents of exponential expressions. And we sometimes call this by its property name, which is power of powers. And the nice thing about that is it gives us a little bit of a shortcut. So let's say I started off with this part here, x cubed all raised to the fifth. Well, that's x cubed 5 times. So I'd have one of them here, 2, there's 3, there's 4, and there's my fifth one. So I'd have all of those things written out. Well, then I could know that I add up their exponents, right? Same base being multiplied together. I add their exponents. Okay, so it's 3 plus 3 plus 3 plus 3 plus 3, which gets me x to the 15th. But that's a whole lot of work. So I could take this shortcut, which is power of powers. If I have x cubed, and I raise that to another exponent, so x cubed raised to the fifth, I can multiply those two exponents, and that just gets me shortcutted way to the 15. Let's check out some examples here. So I now have p squared raised to the third, and I know now that I can just multiply those two exponents. So 2 times 3, which gets me p to the sixth. Then I've got this next chunk. There's two things in there, a squared and b squared all raised to the fourth. That is actually going to get distributed to both of them inside my parentheses there. So a squared raised to the fourth gets me a to the 2 times 4. I have b squared, but it's still raised to the fourth, so that's times 4, which is a to the 8, because remember, I multiply these, I don't add them. Don't write a 6 there. And then I have b to the 8 as well. Then my next one. This one's a little bit scarier looking because there's that negative in there, but these are not any more challenging. I still follow the exact same rules. So I have x cubed raised to an exponent, so I have x cubed times that exponent. And what is 3 times negative 2? Well, that's x to the negative 6. My only problem here is I don't like writing stuff with a negative exponent. So I move it down to a denominator, and that makes my exponent positive now. If it's negative in the numerator or negative on top of a fraction, then it's a positive on the bottom part of a fraction. All right, next examples. And here we go. Ooh, this is a new one. We now have a number in our set of parentheses. It's same protocol. I have a negative 5, and it's getting that 3 exponent, and I have an x squared, and it's getting raised to the third power. And what is negative 5 cubed? Well, if I don't have a calculator, that's negative 5 times negative 5 times negative 5. These two will get me a 25, and then I still have to multiply by a negative 5, and it gets me negative 125. Your teacher lets you use a calculator? Awesome. Type that in. If you're using our Odyssey program, type that in. Negative 125 for my negative 5 to the fifth, or sorry, negative 5 to the third. And then I have x squared raised to the third power. I multiply that 2 and that 3 together, and I get 6. Then I've got this one. My top, I'm just going to leave it the same. You don't have to worry about that part. And then I have x to the fourth raised to a negative 2. We've done that kind of stuff before, right? That just means I multiply those two exponents together, and 4 times a negative 2 is going to get me a negative 8. But I don't like that this exponent is negative. I need to make a positive, so I'm going to move it to my numerator. It's already on the bottom, so I can't move it down there. I'm going to move it up to my numerator. So now it's an x to the positive 8 because I've moved across that division bar. Anytime I move across that division bar, it goes from a negative sign to a positive sign for my exponent. Next one. I have a negative 4 that needs to be squared, and I have an x cubed that needs to get squared. Well, negative 4 squared is negative 4 times negative 4, which is 16. X cubed squared, or x cubed times x cubed, or x to the third times that 2 then there, right? And that gets me 6. 3 and the 2 get me a 6. And that is it, folks. Thank you for watching, and I hope you have a great rest of your day.